The next instruction that I want to discuss is divide. As you can see, the generic syntax of this instruction is very similar to multiplication. There are only two parameters. As you can see, the remainder store in high register and the quotient of the division store in low register. Let me show you one example about the divide in instruction. Assume that we want to write a program to read the number and determine is it even or not. Well, in order to determine a number is even or not, you should divide it by 2 and check the remainder. If it is equal to 0, we say that the number is even, so I need to put number 2 inside a register before performing division. Now the input number will be divided by 2. And the remainder of this division will go to high register. Okay. Well, I should check the high register. Branch equal. But we can't check the high register here. We should put it. We should first move the data off. Move the result from the high register to another register. Move from high register to T.
Label yes.
For example,
And jump to the end.
If the remainder is 0, we go to label. Yes. Otherwise we should print that the number is odd. And jump to the end. This is the US labor. We have a print event message
5.
And this is the label and enter the number where the number is even, 1 it again. 5. The number is up. In this part, I want to write a program to read 5 numbers from the keyboard and find their summation, and also their average, and print them on the screen. These are the messages that I need for printing the sum and printing the average. I declare sum message and average message I need for loop. I use registered $70 as the loop counter, and I use registered $0 as the sum variable, and initialize it with 0 and registered T1 for $1. T1 initialize with 5, which is the number of input numbers. I show a message, ask the user to enter a number, and by this system call, I read one integer number from the keyboard system called number 5, and the answer or resolved is inside register with 0. I add the input number to the previous sum and store it in the sum variable. In this case, registered $sign as 0 is the sum. So we add the new data to the previous summation. After that, we increase the loop counter by 1 and we check it. Branch if not equal to T1. If the counter is not equal to the 5, come back to the again label and again show another message with one integer from the keyboard and add it with the previous sum and increment the loop counter. This loop iterates 5 times and then we reach to this line. I showed some message by system call number 4, and then the summation should be print. For this purpose, we use another system called system call number 1. So I have to put the number that I want to print inside. Registered $sign a 0. The summation is inside register 0. Here we compute it. Now I want to print it. I should put it inside register $sign a 0. So by this line, it's 3 lines. We can print the value of the 0, which is the summation of these input numbers. And finally, in order to compute the average, I should divide this summation by the number of items. We have register T1 here, which holds the number of elements 5, so we should divide the summation by 5. Here we divide the summation by 5. The remainder goes to high register and the quotient goes to low register. These 3 lines only show a message, average equal message. And then here, the system calls for printing a number. My number is inside low register. So by move from low register instruction, I move this data inside the register, a $0 and a 0. And by calling the system call number 1, we can print this result on the screen. So in this part, we print the average, and in this part we print the computed summation. Let me run it. As you can see, I should enter some numbers. 10. After I entered 5 numbers, the systems showed their summation 150. and if you divide this number by 5, the average will be compute and it is 30. Thank you for watching this video. See you later.